Hi guys, I'm back again. Let's get into another video. I'm going to combine a few elements from our operators. Then we're going to the next statement, which is conditional statements. So I'll call this one conditional statements, but I will also add a few elements that we had left out or that we can work with in terms of our operators. So some of the things that we have will just make this lesson a little bit unique, but it will get into operators and some of the things that we need to make our code more user-friendly. So here's what we will do. I would want us to create our variables, which will be as follows. The first variable will be int num. The next variable would be test1. The next variable will be test2. These will be our variables, and we'll try and work with them as we go along. Let's just initialize num to 12, test1 to 15, test2. We'll then make test2 to be 18. Okay, so part of our operators will be as follows. We would want to be able to get the size of a specific value. So there is a size of function that we can work with, and the size of function pretty much gives us the value of each and every element that we've got. So we can actually use our size of for many data types that we've got. So we can actually then say, for this example, we want to get size of our variable, and then we get maybe variable num equals, we put a %d, we put a new line, and then after that we then actually try to get the size of that particular variable. So we can have a size of, we open and we close brackets, we then put num. That way when we run it, we'll be able to get the size of our actual variable. But size of does not only work this way for a variable that we have initialized. We can also have size of for each element that we can get as a data type, so to speak. So for example, I can actually copy this line, control copy, control paste. I then get the size of variable. This time we want a character variable. I'll just change, no, I won't change that. I'll just put the size of char. I'll also do the same with the other two options that we've got. We want a float variable, and we want a this double variable. So I'll just change that to double. I'll also change that to float. Right? As we run it, we're then supposed to actually get the size of each and every variable. So the first one is our num. So we get the size of the variable num, which is equal to 4, which simply means we're actually getting the size of an int variable. We also have the size of a character variable, the size of a float variable, the size of a double variable. that's pretty much how we actually work with our size of. So this actually helps you to calculate the amount of memory that your computer would need if you're working with specific elements. So what this also then means is we can be able to calculate how much in terms of processing power our project or our program would be taking. So we can also work with the following. Let's say we want to be able to get an address of a specific value. To do that, we can actually get to do it in two ways. So I'll just put comments to say address for a given variable. Okay, so to actually do that, we've got two things that we can do. The first one we can do is we can actually have a printf, and our printf follows a question. Please enter a positive integer. Okay, this positive integer will then be received by a scanf, and our scanf will then have the following. And our variable, which is num, like that. At the end of the day, we can actually now be able to see what this does. To state in the least amounts of words, we can say printf, and our printf gives us the value for num. So value for num is %d, and we get a new line. So we get num, and if we run it, it prompts us, please enter a positive integer, 88, and the value for num is 88. So in other words, when we've got our and sign there, and sign allows us to get keyboard input. Okay, we can also do this example in a slightly different way, whereby we can actually then say the following. We want to be able to get the particular address of a specific variable within memory. So we can say the following: test1 is equal to ampersand test1. Okay, and we can also say this, the following as well: test2 is also equal to ampersand test2, like that. Sorry, I had messed up there, but corrected it. So we can actually now be able to display the values of test1 and test2 within a printf. So we can say printf, and then with our printf we do the following. We then state that we want to be able to see the address in memory for test1 and test2. So we then say test1 is %p and test2 is %p, like that. And then at the same time we would need a new line and would want to get the values of test1 and test2. So we say test1 and we say test2, so that when we run it, we'll need to enter a positive integer, and after entering our positive integer, we'll actually notice we can get the addresses of test1 and test2 using our ampersand sign. Okay, so this is what we were hoping to work with our conditional statements. I was hoping that we can use the same project, but I'm noticing that we've got a little bit too much code. Let's just create one more project and we see how conditional statements work, or conditional programming works. So I would want us to work with conditional statements, and we want to work with if statement. That's the statement we want to work with. So we have seen what if pretty much does, but maybe we would need to have a background of what an if statement does. So what we are saying with an if statement, we want to be able to state a condition, have an action that comes after that condition, and we see how that works. After that, we also can be able to have an if-else statement, which comes after the first if statement. So the if statement pretty much means we've got our keyword if, we open and we close brackets, we've got our condition. Outside of our condition, we've got a statement that comes. So in essence, we are then saying at any given point in time, we want to be able to state what we want our program to do. So let's just remove what we've got in the conditions section, and let's have something that we can also have in the statement section. So like you noticed before, we'd need a variable as well. So we've got int x is equal to 10. Oh, I actually put 19. It's actually supposed to be equal to 10. And then we are supposed to say if x is not equal to 0. That's where our operators come into play. We're saying if x is not equal to 0, then we want to be able to print f, and printf should give us a value that reads true, right? So if this is the case, we want to be able to know that this is true. So is x equal to 10? That's the declaration. So if our x is not equal to 0, we want to be able to print true. So if I run the program, it will actually tell us x is not equal to 0. Okay? So in other words, we're then saying if we wanted to change this, we would actually need to just play around with the conditional statement, which is in these brackets right there. But as it stands, we can then be able to get what it is that we want to see. But we also said we can also have an if and else statement. So I can put a comment there and say if and else statement, right? We can still work with our x because x still can be used in another section. So we've got if, and then we've got our curly brackets, and then we've got our else, and then we've got our curly brackets. So what this then means is we want to be able to find something that we can compare with x. So we can then say if x is equal to 11, we want to be able to print either true or false. So we can just copy this line of code, come there, paste it, come there and paste it, and then we want to be able to change that to false, like that. So what that then means is if we run it, we're supposed to get two answers. The first answer is for the first part with our if x is not equal to 0, and that is true, and if x is less than or equal to, if x is equal to 11. So the two equal signs actually mean we are assigning the left and the right operands to get the value that we would want to actually work with. Okay, that then becomes the basic layout of our if statements. Although it does not mean this is the only way we can do it. We can also have more conditions, right? Because you'd actually notice that when we were working with our if statements, we could have brackets. So what that then means now is we could still rewrite the two statements into one statement and have a result that we're looking for. So we can say if we open brackets and we say let's have two sets of brackets as well, where we are saying x is not equal to 0 and x equals to 11, like that. That way we can then be able to copy this code as it is, paste it underneath. Then we can also be able to run it, because now we have combined these two statements into one, and it should give us pretty much the same result. So we are saying now with the first statement from line 7, it is true because x is not equal to 0, so that's true. The next statement, if x is equal to 11, that is false, so it gives us the false. And then now when we go to combining the two, we are getting a false simply because one of the two is not true, so it gives us false. That is how our if statements pretty much work. In the next lesson, we will try and add more to our control statements and maybe work with a nested if